disabled until you either replace the charcoal canister or give it a couple days to dry out in the sun. That's not good. So to prevent that, the newer bikes, right in line, right there between the vent and the gas tank and the charcoal canister, put in a rollover valve. So if the bike somehow goes 90 degrees off true where it's supposed to be, it shuts off that line so the gas tank can't get in there. Some of the 1980s vintage motorcycles in California did not have that rollover valve. And if the bike fell over, you may as well get a truck. You're not going anywhere. You're kind of done. The newer ones all have a rollover valve. Here's a rollover valve. Again, it's a weight. It's spring loaded. It's a very, very weak spring because the weight can overcome it. And when the bike is upright, the weight's pushing straight down. But when the bike falls over, the weight's no longer has gravity pulling on it. The spring pushes it over and shuts off the fuel. It's almost like a tilt mechanism in the pinball machine. I saw the first ones of these on Goldwings. Oh, the automobile industry has these too, so if you flip your car, it shuts the fuel on the engine, so the help prevents some of the car fires. Can't stop everything. Now, remember I said there's some problems with government-mandated adjustments, those government-mandated lean mixtures. And I said the idea was this is what the government was doing. Again, these are not engineers that made these decisions. These are politicians that made these decisions. Decided that by having less hydrocarbon going in, a mandated lean mixture over here, I'd have less unburdened hydrocarbons over here. The problem with this is that by running it intentionally lean per government regulation, the combustion chamber temperature goes up. It gets warmer. It's hotter in the combustion chamber than it used to be. Engines run hotter than they used to because of this. At high temperatures, something interesting happens with the nitrogen. Nitrogen is an inert gas. It's really stable, doesn't like to combine with anything, and so it's very useful. We use it to fill telescopes, for example. Binoculars are often nitrogen filled so they don't fog up. Very unreactive. People use nitrogen in their suspension parts, so it doesn't change with ambient pressures or anything like that. People sometimes, especially BMW car drivers, have gotten into this weird use nitrogen to inflate their tires. I personally don't see the point, but and I've got 4 of them, so I'm not a member of BMW. Pretty much anyway. The nitrogen gets weird though at high temperature. Temperature gets hot enough, nitrogen can now combine with oxygen. It didn't used to. So that gives me a new pollutant over here. I get NOx. The X is just some number, so that's going to be NO, NO2, NO3, etc. These are oxides of nitrogen. Oxides of nitrogen are these. This is not nitrous oxide. Incidentally, when you hear about this stuff on television and this sort of thing, they refer to it as nitrous oxide. This is incorrect. Nitrous oxide is N2O, not NO2 or 3 or just NO. N2O is nitrous oxide. We'll be talking about nitrous oxide in 3 weeks. Yeah, about 3 weeks. We'll be talking about nitrous oxide as something to use for high performance. Everyone smiles on nitrogen. But it's not this. These are oxides of nitrogen. These are bad. This can be good. This is also what the dentist gives you as an anesthetic sometimes. It's also called laughing gas. I know it's been used recreationally by some people. Particularly if they're hospital employees. They tend to use it recreationally. It's hard to find medical grade nitrous oxide that you can use for that. They do sell nitrous oxide at speed shops and high performance shops, but don't breathe that. Even if you are tempted to use the stuff recreationally, I suggest you don't, by the way. You do need trained medical personnel standing by because it's really easy to accidentally suffocate with that stuff. But the stuff that you buy at speed shops and for high performance systems has some additional stuff in it to make you ill if you try to breathe it. They do that so they'd be allowed to sell it. So you'll get very ill if you use that stuff. The only pure nitrous oxide I think you can buy is if you buy like a couple cases of whipped cream. Ready Whip uses pure nitrous oxide as their propellant. And it's a real expensive way to get high. I think that I would rather buy a bottle of scotch. Anyway, so it's not nitrous oxide. We'll talk about nitrous oxide in a few weeks as a performance enhancer. It's a really good one, by the way. But the NO2, NO3, these are oxides of nitrogen. They're caused by the government-mandated lean mixtures forcing up our combustion chamber temperatures and creating these things. This is that pink stuff. Remember when I showed the picture of LA today? I said there's a little stain on the horizon? Those are the oxides of nitrogen. When you come look over the water in Santa Monica, you're looking over Santa Monica Bay and the birds are flying up here, you get this brown smudge across the horizon. That's caused by the oxides of nitrogen. When you're coming from Palm Springs, and you're going up past Indio and around there, you see this orange-brown haze in front of you heading toward LA. That's the oxides of nitrogen. They cause burning eyes, scratchy throats, asthma. The rise in instances of asthma can be directly blamed on the increased oxides of nitrogen that are going into the air from our motor vehicles caused by the government-mandated lean mixtures. It also makes for some really nice sunsets. When the sun goes through the nitrous oxides of nitrogen over the water, you get this brilliant orange and purple sunsets. They're really gorgeous. Doesn't require filtering through heavy pollution to do that. Now, the obvious solution, it was a government-mandated lean mixture that created this problem. What is the obvious solution? Is back off on the lean mixture. So you enrich the mixture a little bit, maybe handle the pollution elsewhere. Like, say, air injection. They'll burn it in the exhaust pipe. That would take care of it. If you had a slightly richer mixture, the oxides of nitrogen would be naturally reduced because the combustion chamber temperature would go down. But that would also require that the government agency admit they were wrong. Is that going to happen? No. Not going to happen. And so instead, we had to find another way to reduce the combustion chamber temperature while still maintaining our lean mixtures. And we do that with exhaust gas recirculation. With exhaust gas recirculation, what we're doing is we take a little bit of exhaust gas and reintroduce it into the intake, into the combustion chamber. Now, we're not running it through the horse again. We're not taking the unburned stuff and out of the exhaust and swinging it around and reburning it. We're not doing that. What we're doing is we're taking about 10% of the exhaust, a little bit of it, and reintroducing it in the combustion chamber, and that reduces the combustion chamber temperatures to help reduce the oxides of nitrogen. You're not reburning the exhaust. The exhaust gas is only introduced, again, when you're in cruise mode, in that mid-range setting. You're not going to be having the exhaust gas going into the intake at idle, and you're not going to have it at wide open throttle. It's going to be occurring only when you're in cruise mode. And that little bit of exhaust gas in there reduces the combustion chamber temperature. This is a pollution control that I predict was going to be found on motorcycles. I hope I'm wrong. But if it's there, now you're going to know what it does and why. You're also going to see how it works in your car. If you have a car, you've got one in there. If your car was made after 1973, you have one of these. This is a typical valve. It's called an EGR valve, exhaust gas recirculation. It is, once again, vacuum operated. It uses an intake manifold vacuum to operate this pollution control. You can tell by what your vacuum is in the manifold, what state of engine you're in. Yes?
Is the exhaust amount the same for automotive, the percentage of exhaust that's recirculated, or is it a different percentage of exhaust gas? Versus motorcycle, you said
motorcycles don't have this yet.
Oh.
But I predict they will, and they'll probably be the same, just a little bit. So this is vacuum operated, and when the vacuum pulls on, it's going to pull the diaphragm up, and takes this little valve, little mini pintle and seat valve, opens up, It allows exhaust gases, that's right, got to be right at the exhaust port, to be cycled back into the intake port. Just a little bit of them. There's several different types. This one's vacuum operated only. This is what it looks like. It's about this big. It's usually bolted right to the side of your engine, adjacent to an exhaust pipe, which you see this one is right there. This one actually has a heater included there. It's electrically operated as well. This one is only vacuum operated. This is a very simple one of the early ones. And here's the vacuum operated one. Here's the butterfly throttle, and the vacuum tap for this is right behind the butterfly throttle. So this is going to require a modification to the throttle bodies or to carburetors to accept this. And that vacuum, we're at partial opening right now. We'll do a little bit of vacuum, open this valve a little bit. Some of the exhaust valve is then reintroduced right into the manifold there. There's also one that is temperature controlled. This one has a coolant temperature sensor, so it screws into the water jacket, which then adds a bit more control to the EGR valve. It's still vacuum operated, but it's modified by engine temperature. This way the EGR is not functioning until the engine's at least warmed up. When the engine's warming up, it's having enough issues. And so this helped with the engine warm up with this pollution control in place. Once the engine warmed up, then this worked normally through a vacuum. And then we had a computer controlled one that just bypasses the vacuum altogether. It takes the input signals for temperature, throttle position, engine speed, road speed, and decides how much exhaust can be introduced. This one obviously gives us the most control by having computer control at all. It still works the same way. It takes a little bit of exhaust gas, sends it back into the intake to lower the combustion chambers. This is probably the system we're going to have on motorcycles. Probably have it this way. By being computer controlled, it means we don't have to be that close to the exhaust port either. And so we can park this other places around the motorcycle frame. The car guys, they have plenty of room to put this in. They can bolt this straight to the engine. Now here's how it works. These diagrams are courtesy of Heisler, wrote a book called